All right, everybody, let's get started. First off, welcome. This is the first in what we're calling the Imagine Academy quarantine sessions, something that we're doing to give everybody kind of a welcome distraction and a chance to educate themselves and learn a bit throughout this slow period that we're all kind of working together to get through. So first off, thank all of you for joining us here today. This is our first session for the Imagine Academy quarantine sessions, focused all on digital denture design and preparation for 3D printing. Joining me today, I've got George Cowburn. He's the co-founder of Perfit Dental Solutions. This is a firm up in Canada that specializes in producing the most accurate fully digital dentures available on the market. So they're really an industry leader in the area of digital dentures. So we're glad to have George with us. He's going to be walking you through the design aspects in Exocad, and I'm going to be bringing him up here in just a second. But also with us, we have Adrienne Slevin, who's the dental applications engineer for a company called 3D Systems that produces the NextDent 5100, which is definitely one of the leaders in the industry for dental 3D printers. So Adrienne is with us today. She's going to be giving us a tour of the 3D Sprint software, which is what we're going to use to slice up and prepare the designs that George does and get them ready for printing in the NextDent 5100, which we're actually going to demonstrate during tomorrow's session, which is happening same time, 2 p.m. Eastern, 11 a.m. Western time. So be sure to tune in with us for that once we get that going. But before we bring George up here and let him get started, a couple of quick ground rules. First off, you can have your mics off throughout the whole presentation today. We're not going to be taking audio questions from the audience, but if you do have any questions, you can send them directly to me on the chat function here on Zoom. There's a chat button down at the bottom of the screen, and you can message me directly. I'll be reviewing all the questions throughout the presentation. And then we will have a Q&A section at the end, right about 2:45, 3 o'clock. And we'll keep that open for as long as folks have questions. So if you have any questions throughout the presentation, jot them down. Chat them to me, I'll keep track, and we can bring them all up at the end and talk about them for as long as we like, because we got some time on our hands. So mics off, cameras off, we don't need a video presentation from the attendees. Q&A at the end, and yeah, likewise, if you have any problems with the presentation, if somebody isn't loud enough or if their video is laggy, shoot me a chat privately on the chat function, and we can try to address that. So without any further ado, I'll introduce George Cowburn of Perfit Dental Solutions. George, everybody should be able to hear you now and see your face there. Hey, George.
Welcome all. Thank you very much for joining the Scruffy Beard sessions. So yeah, I just go a little bit over Exocad and how we do digital designs in Exocad, and a little bit about how it's different from the world that we used to live in. So, well, excuse the pun. So what we'll basically start in is the overview of who comes to Exocad looking to design dentures. And what we've found is generally there's two camps. There's dental technicians that are already familiar with how to use Exocad, people from the Crown and Bridge world mostly. And then there's denture technicians that have been primarily used to waxwork and traditional processes that are now looking at Exocad as a way of making digital designs. So depending on which camp that you're in and which way you're approaching it, it's a little bit different. But the nice thing is that there were rules in the old world that thankfully we don't need to pay attention to anymore in some ways, or we don't need to be confined by. So one of the biggest rules that we had was basically on manufacturing. When you're manufacturing using pre-manufactured denture teeth, like is how every wax-up technician used to work, you're confined to those geometries. And so we would spend a lot of time, say, grinding the backs of teeth if they didn't fit, or we would have to grind the sides of them if they didn't fit laterally. So we were constrained by the libraries that we had available to us, and we had to work around in that world. And they have recreated that in Exocad. So if you want to use pre-manufactured teeth, this is something that you can do. You import the geometries of the teeth, and then essentially you're like in the old world where you're arranging teeth of a preset dimension, and you're just being an arranger. You're not designing the teeth, you are arranging the teeth. Now what we're going to be doing is we're going to be focusing on a 3D printed application. in this world, we're not confined anymore by the libraries that we have. And as we'll see in the presentation ahead, we can change the size and the shape and scale the teeth in ways that we could never do in a traditional pre-manufactured tooth world. So that's the manufacturing method that we're going to be using in this particular example. But it should be said that you can use ExoCAD to design it based on whatever your manufacturing endpoint is. Today, we're focusing on 3D printing though. So I'm going to start here by going over a bit of our design from the very beginning. So we're going to be inputting our patient name like we always do and selecting our teeth. And then we're going to be scrolling down and picking our full denture option and how we plan on doing it. In this case, we picked mill there, but we're going to be printing in this respect. Selecting our teeth, we want to do an upper and a lower, so we'll be selecting both arches. And this is where we can also select how we're going to get our input. Is it going to be stone models? Can we use intraoral scan data? There's different ways of doing it, and then we can discuss the different inputs later on. In this case, we're going to be using 2 stone models in articulation, which we've scanned using our box scanner here. So there's our upper jaw, lower jaw, and we also have our bite block. Our bite block in this respect is where we're going to be getting all of our aesthetic information. So our midlines and our plane of occlusion will be determined by the bite block that we've inputted and scanned. So we're going to be selecting from 3 points here to define our occlusal plane. So it'll prompt you to do left, right, center. And then we can offset them if we want there. That looks good. So we're just going through the wizard right now. We're going to be identifying our landmarks. So we're going to be first identifying the incisal papilla, then both tuberosities. Then we're going to be automatically getting the center line based off of the 2 tuberosities. In this case, we don't need to change it because it looks good. Then we're looking at the position of our laterals. And so this is dependent on how you want to do your arrangement. This is just an approximation, so you don't have to be exactly perfect. These are our first premolar locations. And then we're defining our retromolar pads. Again, because of the retromolar pads, it'll give us an automatic midline. This is where we have the opportunity to move it, but it looks pretty good right now. So now we are identifying the residual alveolar ridge, and we can make minor modifications to this based off of the landmarks that we've already placed. So this is where our first molar is. Again, if you go into the philosophy of tooth arrangements, the first molar will usually be where the tissue starts to ramp up. So if you look at it from the side profile, that's where we'd like to put our first molar. So you can see our teeth in contact there. This is where we're going to be picking our teeth. Now you can see here we have a lot of space in between there. We're using a generic lingualized setup in our posterior here. We're going to go to ruthenium. So we can change up the different posteriors. And this is, again, where we have different spacing. We can choose which particular posterior arrangement we want. If we want to drop a 7, if we want to drop a premolar. It gives us the option in that respect. And it also gives us the occlusion as it's going to be idealized based on our plane of occlusion. So this is where we're going to be picking our different anteriors. Now you can see here that when we pick them, they're not scaled right. We're not at the right size, but this is, again, because we're no longer conflicted and restricted by our tooth libraries. So now what we can do is we can start to scale our teeth, and we can start to modify their shape so they're more appropriate for the size that we have to work with. In this case, we're working in chain mode, so all the teeth are moving all at once. What I like to do first is I just like to get the generalized setup of where it is, and then what we do is we do more of the fine-tuning later on. So at this point, I'm just trying to get my plane of occlusion correct, trying to get the alignments. And now is where it was a little bit extreme on our lingual inclinations of those teeth, so we want to move them down a little bit. We'll have the opportunity to adjust it if this creates any interferences. Sometimes the buccal cusps of the teeth will create interferences if they're hanging down too much. In this case, it was a lingualized setup, so we wanted to lift up those buccal cusps a little bit. Now we still want to maintain our compensating curve here so that there is a bit of a ramp up. This is already included in the design of the posteriors when they first come in based on the plane of occlusion. But you can alter it as you like as well. So now I like to get the teeth at a more appropriate position by individually moving them. Chain mode gets you close, and that's what I like it for. But I like to, because again, I'm used to this as a world wax-up world, get them close and then do fine tuning one tooth at a time. This is where I get my overlaps to be just the way that I used to like them. And this is again where we get into individualized preferences. Some people like to have their setups a certain way. Different clinicians will demand different arrangements. So this is again where you're able to have the freedom that you did in the old wax world back in the digital world. You're just using a different tool. Now, this is where you can spend a considerable amount of time fine-tuning it and making sure that it is just perfect the way that you like to do it. Now, it should also be mentioned that dentures are one of the highest remakes of most things in dental lab, and it's because of the information. So a lot of times, the reason we're doing try-ins is to verify the bite. Quite often, the bite information won't be perfect coming from the clinician. So this is why we really like to do try-ins and to make sure that things are ideal before we go into the manufacturing. This is what 3D printing has been a game changer for, in my opinion, as we're able to print different iterations and really make sure that the patient is very satisfied with the end result, as it's not very costly for us to make different arrangements. In the old world, when we were moving teeth around, it would cost us hours, and we would never want to entertain someone that wanted those extreme number of try-ins. But now we're easily able to accommodate those people. This is where we're going to be freeforming the anatomy here. We're cutting the intersections anywhere that we've moved things where they are going to be interfering. Again, this is where you can move the tooth so that you can remove the interference, or you can cut the interference as well.
Hey, George, we had a couple of questions here from the audience. You mentioned chain mode and you were using it earlier.
Yeah.
Can you explain what chain mode is real quick, maybe for somebody who's not familiar like that?
For those not familiar, chain mode moves many teeth at once. So instead of just grabbing a single tooth and moving it individually, what you're actually doing is grabbing the anteriors as a block. And you could see how it kind of stretched out and it kept moving every tooth in the same amount. So it allows us to move teeth in blocks instead of individually, one at a time. Saves a lot of time. But again, I like to use both. It gets it in the right neighborhood. Then I like to use the individual tooth to get it just perfect.
Great. And one more we had, when selecting the teeth, there's a number in red or green. What is that number indicating? Hopefully that's
tooth
for you.
The tooth number.
It's just the tooth number. Got it. Perfect. Thanks.
Yeah, so this is again when we're doing the base, I like to do a first over very quick and just get the general shape. What I like to do is go in afterwards and fine tune my reliefs. So the areas where I have reliefs for around the frenums, again, I'm gonna just do a rough once over, but when I go in afterwards, that's when I can zoom in a lot better and make those fine tune adjustments. So this is giving us a rough idea of the wax up base. Too high for milling. We're not milling, so it doesn't matter. And same thing on the lower. What I'm doing is I'm going to the outside roll of the vestibule there, of the sulcus. And the reason that I do that is that when it gives me my final wax up, it's going to include that roll as part of my design. Otherwise, you can sometimes leave your denture a little bit short and underextended. So here's the part again where I like to go in and try to do a much better job of the frenal reliefs. Again, if you do a more careful job here, you can prevent a lot of post-insert adjustments for your clinician. And so just like in the old world, wax up is probably the area that it took the longest to figure out in the digital design world. In the first version of denture designs, it was, I think I'm being kind when I say it's atrocious. It took forever, and the waxing tools definitely have come a long way. Right now, what we're doing is we're looking at the bridge mode to be able to connect the teeth. Because we're going to be printing them or milling them, we want them to be in one bridge so that when we're putting them together, we have one arch. Now, normally they will put the connectors, as you can see a little bit lower down. I prefer to have a more natural arrangement. So that's why I pull my connectors up and I put them more closer to the normal contact closely with the teeth. Sometimes it'll show over a little bit on the lingual side. So we're just going to push into the center of the tooth there. We're going to have an ability later on to adjust anything that does stick out a little bit here. Now this reduces a lot of the potential for error later on when we're seating these teeth in, like Adrienne's going to show later on tomorrow. So that if we have them all joined together, it's a lot more accurate. Again, this is kind of an homage of the old wax up world. This is what we used to do in the old wax world, where we would overbuild and we would make large reliefs. And I would do this in wax. And then after that, we'd go back with our torch, and it would naturally smooth out the contours. So we're just basically using the exact same philosophy. We're just using digital tools to accomplish the same goal. So we still get really nice festooning in between our teeth, but we don't have those roughnesses that we had before.
Hey, George, quick question.
Yeah, go ahead.
We have Samira asking, how can we do a relief to avoid an undercut or offset?
So you can do that beforehand when you can alter your model before you bring it in. But you can also, especially like in the partials, that's where you can have the ability to block out undercuts. So if you want to, you can block out undercuts at that point. Now, this is again where the standard wax up isn't the way that we would normally wax it up. So you can see the algorithm that they're using here to do the wax up kind of leaves a straight down hollowed technique out. When we were doing wax ups, we didn't really do this. So what we're doing now is we're adding bulk areas underneath, say in the palate area, and then we're using our smooth tool to go back and smooth out those areas. And this gives us more of a traditional wax up that we're used to seeing when we were doing it in the old wax world. So still, some of the automated programs that they have, are still not ideal, but they get us really close, and it doesn't take very long for us to fine tune it to look like we want it to. Same thing too. So we're just looking in the retromolar area, the lingual area there, and that's where again we like to have a little bit more of a contour there. It kind of tends to go straight down in the design of the automatic gingiva. We like to give it a little bit more body. Same thing around the teeth here to give them a little bit more of a profile that it actually looks a little bit more natural. Now again, we start to do the festooning. I find the festooning great on the anterior 6. I find going back in the posteriors isn't as necessary. Good. So now we're going to be adapting the denture base to the teeth. So again, this is where we're choosing the minimum thicknesses and the pocket gap. So this is the distance from the bottom of the socket to the denture base, and also how big it is, the gap between the teeth and the base. In this case here, we also have an angle for milling because we have this as an offset. So this will be the angle that we are going to be having as a maximum angle. Now, because we're printing, we're not going to be confined by these. This is drill compensation, more intended for when we want to mill these dentures instead of printing them. But we still need to have minimum thicknesses and gaps when we're printing. In this case, we picked a 0.2, but I think we revisited, came back on this one, and we did a 0.3, and that's what we'll be testing.
Hey, George, real quick question here from the audience.
Yes, please.
Paul was wondering, when waxing the palate, how can you mimic the patient's rugi?
You can do that by taking the original rugae, and you can do like an extrusion if you'd like to. So there's a few different ways that you can do that. Yeah, that's kind of a more of an advanced option, but definitely is doable and something that we like to do as well.
Great. Thanks, George. So one other question here from Ken Kincaid. So I know we're going over the, upper and lower today. Is the process very different for a single upper or lower denture?
It is quite different for a single denture if you're using pre-manufactured teeth, because when we do a complete upper and complete lower, we can generally just, like I say, arrange the teeth so that they are in the ideal position. When we do single uppers, a lot of times we're needing to adjust the occlusion. Oh, looks like my video is going a little bit funny. So that's the main issue, is that when we're adjusting the occlusion, actually, I have a great video here that I can show you that on. That's where we need to change the morphology of the tooth. And that is not easy to do if you start with a pre-manufactured tooth. So this is where they have jigs and different ways of holding it so that you can make the appropriate adjustments. The best thing about 3D printing is that it makes all that challenge go completely away. So I'll show you in the articulator function, because this is what we did with a single upper. So again, if you're going to be setting teeth, already set teeth to that, you're going to have to be adjusting the occlusion of those teeth. So when we print our teeth, it's super easy for us to go and adjust the occlusion and cut away the offending areas. But when you use pre-manufactured teeth, it's much more difficult. So what we're doing is we're showing you here the articulator function. And so these values here, the bended angles, the side shift, and the condylar angles, these are averages, so that when you do a regular denture setup, you're essentially doing it just like you used to do in the old wax world, where we're going to be setting it to an arbitrary average point. And if you have a face bow transfer, this is where you can have a more accurate input, so that we can get a face bow and be able to input this. Usually it's inputted from your scanner. So they'll either have a magnetic transfer plate like they have down here at the bottom, or you can actually put your whole physical articulator into the scanner, like some scanners permit. So from that, you're able to transmit some of your faceable information. And also, if you have, mandibular tracing devices, like there's several, like the Zebras, on the market, what you can do is you can input the values that you're actually recording from your patients and input it into the area right here. So you can see this is where we're able to input the custom values that we would be taking from those more accurate registrations.
Hey, George, real quick, going back to the festooning process that you were doing earlier.
Yeah.
Question from my friend Dr. Shaw out in Phoenix. Is there any way to do that festooning process automatically rather than going through the steps? Are you familiar with that at all?
Yeah, generally speaking, it'll do. So the algorithms do have customizations for how it will do the automatic wax up, and you can start to change those parameters. I've never found that it gives me exactly what I want, so I'm always, getting my hands dirty, digitally speaking, and doing those. But yes, you can use the automated wax up settings and fine tune it so that you can get it more like what you want.
Great, great. And actually, one more here. Samira was hoping, could you mention the mandibular tracing devices again?
Yes, so there's several on the market. The Zebras is one of the one that's coming out right now. It's quite popular. There's the Arctis Digma that has been around for a long time. I know there's some that are now integrated into CBCT machines. I believe Plan Mecca had a version that did that. So there's lots of different ones on the market. No, one caveat and warning I'll give is for edentulous lowers, it doesn't work as well as it does for dentate lowers. So in this case here, you can see we have natural mandibular teeth. And so the tracing devices are very accurate when you have stable artifacts on your mandible. So whether they're implants or teeth, if you have something physical to anchor to, your registrations are a lot more accurate. If you're like securing your registration device on like a occlusal rim, there is less certainty that it's staying put. And so there's more noise in the results. So we trust them less. Yeah. So the other thing that is great, and this is really the cause of remakes, and that would be with respect to information being wrong, like your bite or your impressions being wrong. But then the second way that you're going to go wrong is aesthetically speaking. So your midline is going to be not perfect. Your plane of occlusion isn't going to be quite perfect. And this is where the technician has such a great gift from new technology. If we can take a picture or if we can take a 3D scan and we can input that information onto our designs, then we can get rid of 2/3 of the reasons for remakes. Now it's only going to be, if I screwed up my bite, because now I can say that my midline and my plane of occlusion should be accurate because I see exactly what the clinician can see. And for a long time, denture technicians were not able to see what the case looked like in real life. All they could do is see it on the articulator. So what we're able to do now is we're able to line up from a 2D picture to a 3D design. And now we can show the patient or the technicians or the doctors different arrangements, and then they can pick from those different arrangements. And because those are digital arrangements that took us a few seconds to make, it's very easy for us to make them a couple and not have to waste time like it was in the old world when we would actually be physically waxing these up. And this is another great opportunity to start to engage the patient in their design. So you can ask the patient, what do you prefer? Beforehand, the communication would be 3 layers. The professional, the dentist would ask the patient what they thought, and then based on what the patient thought, they would communicate that to the lab. And this allows the lab and the patient to almost directly communicate. So the lab can show patients different arrangements, and then the patient can say yes or no or make alterations based off of a couple different recommendations. So this is a 2D data set. We also have the ability to do this on a 3D data set. And we did this with the face snap. So the DOF has the face snap option. And that is a great option. It works with DOF box scanners right now. And what this allows us to do is get very accurate information from how someone's teeth are compared to where the arrangement are, where the face is. So there is a mechanism that DOF has where you bite on this bite block and it has an optical target. It kind of looks like a big QR code. And you scan someone with and without that. And what you're able to do is align the 2 data sets. So when you saw me aligning the picture, we were only aligning the picture from the anterior teeth. When you have a full bite fork, what you're actually doing is you're aligning exactly where the plane of occlusion is compared to the outside of the face. So the information that we're getting from a 3D data set is much more accurate, especially with the DOF face snap, than it would be, for example, if we're just trying to align a 2D picture. Okay. And so, yeah, that is the easiest way that we can avoid, oh, sorry, I'm going to say that we can avoid problems. And that is really the greatest benefit of digital design is, number one, being able to do multiple arrangements without having to really take hours and hours, as well as being able to make changes on the fly. So that if we have something like a bite being off, which happens all the time, now the dentist can simply take a new bite registration and they can send that back to the lab. The lab doesn't necessarily have to change both arches. They can only change one at a time if they'd like to, and just make the alterations to make the bite more accurate. So, it's a really great time saver because we can throw different aesthetic concerns and we're able to be very adaptive from data inputs. Now we get a new bite, no problem. Let's input that into our information that we already have. We don't have to start from scratch like we used to.
Great. Awesome, George. So we're running a little ahead of schedule here. So if anybody has any specific questions about the design aspect, I think now would be a good time. We can take maybe 10 minutes or so before we move on to Adrienne's section. So are there any specific questions for the design aspect? You can put them into the chat feed here and we can kind of field those now. Okay, not really seeing any pop up, which is totally fine. So that gives me the opportunity to introduce my friend, Adrienne Slevin. So Adrienne's going to be walking us through the preparation for 3D printing. So this is operations done within what we refer to as slicing software, what 3D Systems calls specifically their 3D Sprint software. And this is basically taking the design that George has completed in ExoCAD and pulling it into a digital environment to prepare it for 3D printing. So Adrienne, are you there?
I'm here. Hi, everybody.
Awesome. I'll let you take it away. Adrienne, go for it.
Cool. So today I'm going to go over just simply nesting. Tomorrow I will start with a little bit of a review on some design parameters that we encourage you to use for NextDent material, regardless on if you are going to use the NextDent 5100 or your own printer that you have that's not a NextDent printer, but you want to use the materials. So I'm going to start tomorrow with that. Today I'm just going to show you how to nest the designs that George just completed. And I will also go over some of the basic design parameters for 3Shape and ExoCAD tomorrow in the case that you don't have ExoCAD, as well as the properties of the materials and things like that. So tomorrow I'll start with a bit of a review on that, and today I'm just going to show you some nesting. So the first thing that you're going to do is launch your 3D Sprint software, and then you'll choose printer. And I have 2 printers connected right now. So I'm going to choose my Toothmaker printer and hit next. We'll start with the teeth, and as you know, the Crown and Bridge microfilled hybrid material is what we use for our permanent dentures and our temporary Crown and Bridge temps. And then we're going to choose an N1 today. Tomorrow I'm going to go over how these shades convert to Vita shades as well as the denture-based shade options. And we print at a 50 micron layer, and we'll just hit set now. So the next thing we're going to do is hit File, and tomorrow I'll teach some hotkeys as well. And Import, and we're going to start with the teeth. So you can import as many arches as you want. You can fit about 4 onto the plate in the orientation that I'm going to encourage you. Tomorrow I'll show you the best practices so you can do a quick check on that. Now we just have an upper and lower, but you could fit, again, 4 arches. Now the next thing you'll do is hit auto place, and just a couple of little tips and tricks if you guys have the NextDent printer. Just change this to 0, and you can do this with any of the parts that you're nesting. So regardless on what you make, models or anything like that, these parameters work really well for auto placement. You'll hit allow Z axis rotation and go ahead and hit 0 again from the margin line. This is the border around the build plate. And then you'll hit set. Now you can see that it has placed a slight angle, which I actually like to have in my build. If I do a slight angle, any type of horizontal biting surfaces won't have any pump lines at all. So you can really have a nice aesthetic, easy to polish part if you angle it slightly. Now, if you are under a time constriction, maybe you have the patient coming in an hour or 2 for their dentures, you can always use the transform button, or you can use the hotkey Q. And if you hold shift, it'll take it off of that 10-degree snapping. So you can do one or the other. A lot of ExoCAD people like hotkeys, a lot of people do. But if you don't like hotkeys, just use the transform button. And that'll put a bounding box, and you can use that to adjust your angles, okay? Again, if you hold shift, it will take it off of that degree of snapping, okay? Again, if you are at a time constraint and you want to print them flat, this will only take, let's see on here. You can always check and see how long it'll take by hitting estimate. I think my graphics card is overloaded with all this video and everything going on. Okay, so this will take about 29 minutes. The material here is 19 grams of material that needs to be in the build, in the resin tray, in order for it to have a successful print. So that's not what it's going to use for the build, it's what it needs to have to get to the end of the build successfully. Tomorrow I'm going to go over like price per part and things like that, just so you're aware of how many grams per tooth and how much each gram costs. How much will it cost you to print a denture? So after you're done getting your orientation correct, just hit Smart Support. And tomorrow I'm going to go over why you would combine parts. We don't need to combine parts today because we're not overlapping anything, but I'm going to show you a few scenarios tomorrow about what happens when you need to combine or not combine. We do not need to here, so I'm going to hit no. Okay, and just hit create supports. And you don't need to add supports here. Now, if I'm going to show you a scenario where we do on our dentures, but this is perfectly fine. Every downward facing surface is supported, everything that needs to be supported, and all of these supports are very fine tipped. So tomorrow I'm going to show you how to break off the supports and how it leaves literally no scarring. So go ahead and hit X.
Hey, Adrienne, real quick question here from the audience. Ken Kincaid, he uses 3D Sprint software, but he's unable to move the checkered build plate left or right on the screen to recenter for ease of working. He's wondering what he's doing wrong.
Okay, so you're going to hold your right mouse button down and then hold your left and you can pan. So you're going to have both mouse buttons down, but you start with your right.
Great. Hopefully that helps.
You can also, there's a quick views as well. So if you hit view, you can actually just change the views quickly.
Perfect. Yep, looks like that helped. So another one here from Samira. What do you suggest about the length of the supporters? I know 3D Sprint has a lot of logic built into it for the supports, but what do you recommend for the length?
So the distance from the build platform, 3 millimeters. So what I do is I just hold my cue or my transform and I pull it down until it stops going down. So that's the amount of length I would recommend, is keeping it close to the build platform. Now, when you start stacking, we have special types of supports to allow you to go 8 inches up. So at this point, I would always keep it between 3 millimeters at the shortest part. And then if you're going to angle it, no problem. But I don't put a lot of thought into my height. I just pull it down to the max. Does that answer your question?
Looks like it does. Samira, get back to us if that doesn't clarify enough. And then our friend Kyle actually is wondering, when are we getting the new Sprint update? So maybe he's looking forward to some of the stacking functions and stuff like that.
Yes, the new Sprint update will be out this month. We are just finishing up our gate reviews on it and our reliability testing. I am going to show you a couple of new things from the new software that's coming out, so you guys will be prepared. But I would say within 2 weeks, we have our last gate review tomorrow on it to make sure it passed all of the reliability testing.
Great. And then one more from Gus Khalil here. He's wondering, would the support tips have to be touched up so that it will fit in the sockets of the denture base? I know 3D Sprint has really, really fine tips on their supports. Do you really need to touch them up afterwards?
I do not, and I'm going to show you a couple of little tricks on that tomorrow. So if you can pop on tomorrow, I'll show you all the removal and the techniques I would use if, let's say, that one of the tips didn't come off. I have little snips and some fingernail clippers. But generally don't need to, as long as you remove your build from the build platform. Right after it's done printing, the tips stay very soft.
Great. All right, Gus, be sure to join us tomorrow, and Adrienne will walk you through all that.
Okay, so I'm not going to send this to the printer right now. I'll do that later. So I'm just going to hit close. Now, always save your build until you're done and the denture is seated. Just in case something goes wrong, you can always open it back up, or you need some support, or you need a reprint. So when I hit close, I save my project, and I'll just call it, the teeth. And we will do our denture base now. Now, tomorrow I'm also going to review this, but it's important that you follow certain orientations for denture base. So we're going to go ahead, and it looks like I drew a line here on annotation. I'm still getting used to Zoom, so excuse me, guys. Okay, so choose your next dent denture. We're going to choose opaque pink. That's what's in my printer today. And set. And again, you'll do your file import. You can use Control-I if you like hotkeys like that. And we'll just do our bases. You can fit about 4 to 5 dentures in the orientation that I recommend. Okay, so you can see that this is what our base looks like from George. We're going to use auto place. Distance between 0. Allow your z-axis rotation. Distance from the sides 0. Okay, and it'll pop it on that plate for you. Now on your lower bases, I encourage you to put a bar on there, especially if it's going on implants. And this feature is coming out in a couple weeks on the new builds. I do have a video on YouTube to teach you how to generate a geometry and make a bar. You'll only need that for a couple more weeks, so I wanted to go ahead and show you this. All you'll do is click on the area where you want the bar, hit apply. Okay, and now what I would recommend you guys doing, because we don't know the shape and sizes of every type of denture, every patient is different. And so in order to prevent anything, it's called cupping, is what happens during 3D printing. In order to prevent that, what we did is a generic recommendation. We did tons of arches, everything we could find, collected them from our customers, designed our own, worked with large design companies to get as much as we could. We wanted to make sure that we got 100% reliability and accuracy. So make your base, and I use Q for my orientation. We want it to be 65 degrees, okay, just like that. And you can always put, you know, 3 to 4, depending on how many you need to fit on the plate. You can go one at a time or anything like that, okay? But 65 degrees is what we recommend, okay? So I'm gonna go ahead and angle that, and then hit Smart Support. And again, I do not need to, oh, and it looks like this, one of the things I like about Sprint actually is that it will outline it in red if A, it's out of the build platform area, or B, it has bad geometries, something that's not closed. It looks like this one's just out of the build area, so we'll just move it in. You can do a little slight angle there. Okay, now we're gonna Smart Support, and we do not need to combine. Again, I'll show you some examples tomorrow on when we would combine and when we wouldn't combine. Hit Create Support. Okay, and you can see that it's done all of the downward facing surfaces. We don't need to go through slices, which is one of my favorite things about the software. You don't have to check to make sure things are supported as far as floating data and things like that. That's a thing of the past now. But I do always like to make sure that I have a little bit of support in areas that have the potential to sag, maybe a heavy part. So I'm gonna go ahead and add a couple of supports here. I click Modify, and I'm just gonna add just a few supports just so I know that there's no sagging that's gonna happen. Now this would be a perfectly successful print. However, I noticed that when there's large areas that don't have a support, then I will add one just to help support that during the pumping action. So update, never remove supports. If you don't like where the support is, change your angle slightly and then regenerate your supports. When you remove supports, you have the risk of having a floating part, and then there will be some cured material in your resin tray, and you could potentially begin to damage your membrane or have missing areas off of your STL file. So any questions about nesting the denture bases? These are ready to print now. There's nothing else to do.
Nice, those look great.
They will come out very smooth tomorrow. I'll show the assembly of putting everything together, and I believe George is going to show the polishing after that. So that's it. That's all there is to it. Hit Add to Queue, and it'll send it over to the queue. I don't have my printer on right now because it's kind of, I'm in a little office, so I'm not going to add it to the queue because it's not connected. So thank you for joining me. I'll go into more detail about shading and things like that tomorrow and do the full shebang. I'm going to print live and assemble the teeth and clean everything. So
awesome. Adrienne,
thank you.
So much. That was